We've seen how to use Dnsmasq to serve DNS queries, but as we mentioned before, Dnsmasq can also be used for other networking services. Let's look at how it can be used as a DHCP server. A DHCP server is usually set up on a machine or a device that has a static IP address configured to the network interface which is being used to serve the DHCP queries. That interface is then connected to the physical network that you want to configure through DHCP, which can have any number of machines on it. In real life, the DHCP server and the DHCP client usually run on two separate machines. But for this example, we'll be doing a simulation on one machine so that you can experiment with a similar setup in the upcoming quick lab exercises. In this machine, we have an interface called ETH_SRV that's configured to be the DHCP server's interface. So now I'm going to type in IP address show ETH_SRV. This command shows us that this interface has the 192.168.1.1 IP address. The /24 part indicates that this IP is in a network that goes from 192.168.1.0 to 192.168.1.255. If this isn't clear, you may want to review the lessons on IP addressing in the networking course. The interface also has an IPv6 address configured, but we won't go into IPv6 for this example. We also have an interface called ETH_CLI, which is the interface that we'll use to simulate a client requesting an address using DHCP. This interface doesn't have an IP configured yet, so I'm going to type in IP address show ETH_CLI. We can see that this interface doesn't have an IPv4 address configured. We'll change this by using our DHCP server. To do this, we need to provide additional configuration to Dnsmasq. There are lots of things we can configure. We're going to use a very basic set of options. Let's look at the configuration file. So I'm going to type in cat dhcp config. The interface option tells Dnsmasq that it should listen for DHCP queries on the ETH_SRV interface. The bind interfaces option tells it not to listen on any other interfaces for any kind of queries. This allows us to have more than one Dnsmasq server running at the same time, each on its own interface. The domain option tells the clients the network's domain name and will be used for querying host names. Then we have two different DHCP options, which are additional information that will be transmitted to DHCP clients when the IP is assigned. In this case, we're telling clients what to configure as a default gateway and which DNS service should be used. There are a lot more options that we can set, but these two are the most common ones. Finally, we configure the DHCP range. This is the range of IP addresses that the DHCP server can hand out. Depending on your specific setup, you may want to reserve some of the addresses in your network for machines that need to have a static address. If you don't plan to do that, you can make the range larger, but make sure you don't include the address of the DHCP server itself. The last value in the DHCP range line is the length of the lease time for the IP address. In this case, it's 12 hours, which means that once an address is assigned to a machine, it will be reserved for that machine for those 12 hours. If the lease expires without the client renewing it, the address can be assigned to a different machine. Alright, we've gone through the configuration file. Let's tell Dnsmasq to start listening for queries using this config. So now I'm going to type in sudo dnsmasq dqc dhcp config and then hit enter. We can see in the output that Dnsmasq is listening for DHCP queries on the ETH_SRV interface with the options that we set in our configuration file. Now, let's run a DHCP client on a second terminal. So I want to open up the second terminal. Now on my second terminal, I'm going to type in sudo dhc client I eth CLI and then v for verbose. we're using DHC client, which is very common DHCP client on Linux. We're telling it to run on the eth_CLI interface, and we're using the -v flag to see the full output of what's happening. Back in the networking course, we explained the whole process of DHCP client getting a DHCP lease, and here we see the packets being exchanged and how our client got the IP address 192.168.1.80. We also see that the DHCP client expects to renew the address before it expires. Let's see how our interface looks now. So now I'm going to type in IP address show eth_CLI. Our eth_CLI interface has successfully acquired an IP address. Now, let's look at what Dnsmasq printed when the request was made. We see the same packet exchange that we saw from the client, but Dnsmasq also shows that it now knows the host name of the machine with the address 192.168.1.80. Because Dnsmasq also has DNS capabilities, this means it will also provide this as an authoritative answer for local queries. So now I'm going to type in dig at localhost instance 1. And with that, we've seen how Dnsmasq can act not only as a DNS server, but also as a DHCP server. This setup was a simulation to show you what you can do with Dnsmasq. As mentioned earlier, in real life, you would have this on separate machines, physical or virtual. If you want to test a setup like this, you would normally do that on a separate network from the production network. Remember, never test in production. We covered a lot of information in this module. You've learned about the overall services needed in IT infrastructure. On top of that, you learned about the physical infrastructure services like remote access and virtualization that help your organization run more efficiently. You even learned about essential network services like DNS and DHCP, along with the overall picture of what's needed to set up DNS for an organization and why you'd want to do that. And we've seen lots of these services in action. Now, we're going to let you practice with some quick lab exercises and test you on what you've learned. And don't forget, you can always go back and review the material again if you want before you take the quiz. In the next module, we're going to cover 2 of the other IT infrastructure services, software and platform services. I'll see you there.